Um, Hello everyone. I believe some of you were there last time. We have spoken earlier, just review quickly, about some basic ECGs stuff like leads and paper and measurement, calibrations. Then we have discussed about calculating the rate, checking the rhythm, irregular or regular. We have also spoken about axis and about voltage and about the P wave and PR interval and segment. Is that correct? So we are going to discuss about QRS complex today. So I believe it's going to be long, so I'll come back next as well, because a lot of stuff to be discussed there. Some of them even I have decided to postpone it later, like the ventricular escape rhythm and premature ventricular complexes. So I'm going to discuss them in other occasions, not in QRS. Okay? So QRS complex. What does it represent? It represents a ventricular depolarization, is not the contraction. Again. Three components it has. QRS. We don't usually see the three components in all the leads. You can sometimes have a Q, QR, RS, whatever. So it depends about what? Anyone knows? How? Oh, wow. Oh, okay. Again, go back to the first lecture when I put the leads and its relation to the heart. So wherever the leads look at the heart, it reflects what can be seen. Okay, so obviously if I just close my eyes, I can imagine in V5, V6, okay, which records actually the ventricle, the left ventricle, and I can see a very big R there with diminished S and Q if there. Is that right? And so on. I'm going to explain that on steps. So Q wave is the first negative wave can be seen if there. R wave is the first positive wave after the B wave, can be preceded by Q and sometimes no. S wave is the negative wave after R wave. So we expect sometimes two negatives before R or after R. So before R is Q, after R is S. Okay? Okay, it is how it looks. QRS. So the Q is the first one, S is the last one, and R is the only positive beat in between, or wave in between. The relation between the heights of the three waves vary with the lead examined. So it's different from lead to lead. The position of the heart and the degree of the abnormality present, because it does affect it. Okay? Do you remember this? So, do you remember this? I have used it in the previous lectures as well. So usually the lead will be positive in. What is lead one? Here is the current or the electricity moves. So towards the lead is positive. So it will be positive in lead one. I expect it positive in lead two. I expect it positive in AVF, in AVL. Is that right? Simply. Negative in AVR could be plus minus in lead three. Is that right? If we look at here, we expect it, this is the left ventricle, positive here, positive there, more or less equal, because it shows part of it and the part of the right ventricle, and V and V2 mostly the QRS will be negative as well, as the left ventricle is that side and the recording from that side. So we can just have a guess, positive or negative. Okay? That's why lead 3 can be negative normally. Okay. So the electrodes face the right ventricle, which is V1 and V2. what it shows normally? It shows initial upward deflection, which is the R wave, small R wave. And it comes from where? Small upward deflection caused by the spread of the excitation wave towards the electrode. And that negative one is due to what? The left ventricle one. But because it is away from the electrode, it became negative. But what is facing here, they are lead V1 and V2, they face two things, right ventricle and the septum. Okay? But the left ventricle is actually away from it, so that's why it comes negative here. Okay. And this followed by a larger downward deflection caused by the spread of excitation wave in the direction of the left ventricle, as I explained earlier. And this away from the electrodes, as I explained earlier. The result is a RS ventricular pattern. So small r and deep S is a normal finding. This is how you can understand why it is V1 and V2 looks like this way. And this usually seems to be like this. Small r, big S, a little bigger r, but small again small, and bigger S. Okay? How much you can accept R wave in V1 and V2, how much I mean to say amplitude you can accept in relation with the S wave, if it exceeds the S wave or equal to, so R length or amplitude, if we divide it by the length of the S wave, is not supposed to be more than 1 to accept it as a normal. So if the R divided by S amplitudes more than 1, it's abnormal in V1 and V2. Is it okay? The electrode faces the interventricular septum, which is V3 and V4, so it is away a bit from right ventricle and it's going to left ventricle. So you expect the deep S to be a bit short and the R to be more longer. So intermediate pattern, so nearly equal negative and positive waves. So again, if you can observe it here, this is up to here and this is up to here, and V4 are more long, so it's a progressive. We'll call it progression, R wave progression. The electrode facing left ventricle, V5 and V6, record a small initial negative deflection. It's very important to memorize this because I'm going to use it in subsequent slides, especially 5 and 6. So it's recorded a small initial negative deflection caused by the spread of excitation wave in interventricular septum. So Q wave in V5 and V6 is absolutely small Q wave, not pathological. It represents the conduction septum. And of course, it is away from the electrode. And it is followed by large positive deflection caused by spread of wave in direction of left ventricle. That's why the R will be very big. And the result is Q, small q, and big R. Large R, small q, large R. But Q is not pathological. It means less than 1 small square in width or the duration and less than 2 millimeter deep. There is one more point. The R wave is supposed to be less than 25 millimeter. One more point, sometimes we can see S in V5 and V6, very small S, which can represent the right ventricle. So nature Q in V5 and 6 represents the septum. R wave represents the left ventricular depolarization. S wave represents the right ventricle as a negative one because that ventricle now is away from it. Just remember the initial picture I put. Okay. So here V5 and 6, you can QRS, you can see it. So small q records the excitation of interventricular septum. Big S is the depolarization of the left ventricle, and small s represents the right ventricle. So QRS. Complex is a bit complicated because it represents two big chambers. B wave represents two tiny chambers, so no big deals. But here it represents big chambers. Same way in V6. Okay. So how it looks all over: small r, a bit bigger, a bit bigger, a bit bigger, the tallest down. Big S, smaller, 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 very small. It is how the normal progression can be seen in chest leads. Okay, normal duration. So QRS is up to 0.1 second, which means that 2.5 small squares. 2.5 small squares. So can be wide. What is the limitation if we're quite complex? If more than 3. So 2.5 to 3 incomplete. So if there is a bundle branch, you can take incomplete bundle branch. But more than 3 is definite prolongation. 2.5 is normal, and this is normal. As we mentioned in PR interval, so 3 to 5, less than 3 is short, more than 5 is long. But 5 to 6, after 6, first degree heart block. Okay? Again, revising the Q wave because it's important. Q wave normally is less than 1 small square wide, it means 0.04, and it is less than 1/3 of its related R wave. When I discussed it in the chest leads, I give you a figure of less than 2 millimeter because I'm speaking about that lead. But if we speak generally about all the leads, it's not supposed to be more than 1/3 of its related R wave. It means 1/4 of all the amplitude. You understand it? I'll just explain it again. We assume that the Q wave is 1 small square. Okay? I expect the R wave is 3 folds, 1/3. So to be 3 small square at least. So the relation of it to the whole complex is 1/4. Calculate by anyhow you like. 1/3 of its related R wave or 1/4 of the whole complex is the same. It's not supposed to be more than this in length. And it can be deeper in lead 3. That's why I told you lead 3 is query. Can be up to 7 millimeter deep in lead 3, only lead 3. Okay, just put it in mind. Even its widths in lead 3 can be 1 small square, but others less than small square. What abnormalities we are going to discuss? Bundle branch block, either right or left. Ventricular escape rhythm and extra stalls and tachycardia. I'm going to postpone it later. WBW, we have discussed WBW before last time, but from the PR interval point of view. And I have also explained how the QRS came wide last time, but I'm going to discuss it again now. And abnormalities of the QRS height, which is the ventricular hypertrophy. Right and left ventricular hypertrophy as a normal variant as well. So I'm going to discuss also the hypertrophy and how we can diagnose it as a hypertrophy of a normal variant even. To that stage, do you have any question? It's just simple, basic, nothing more. No information here, just to settle some basic knowledge about the progress. I'll just review it again. In chest leads, we have small R wave, big S wave, which is going to progress. We are going to the chest leads to a very small, tiny Q and big R in V6 with very small Q. The most important knowledge I need you to keep in is the Q in V5 and 6 represents the ventricular septum, and the R wave in V5 and 6 represents the left ventricle, and the S wave in V5 and 6 represents the right ventricle. Same criteria applies in lead 1 and AVN because they are all showing the left ventricle lateral. They are all showing left lead 1 and AVN. They again look at the same area like the V5 and 6 does. So Again, you will find a small S wave represents the right ventricle, and tall R wave represents the left ventricle. Is it okay? So that's the only initial introduction, and I'm going to carry on with the abnormalities. Is that all right? Okay.